Hey, it's Tony from Adafruit, and this is the second attempt at doing this stream. So last night I tried to do this and had some microphone problems. Hopefully those are fixed now. So let me know in the chat if it sounds like there's any crackling in the audio or something. I think it was just a low battery in the microphone preamp that I had. But anyways, so I wanted to do a stream on something really interesting that Lady Ada figured out with Circuit Playground. So you can actually use Circuit Playground to detect the color of an object. And you can do a really clever thing just using the little light sensor and a neopixel that's right next to it. So the neopixel is a little RGB, red, green, blue controllable LED pixel. So you can light up the neopixel with different colors, and then with the color sensor that's right next to it, and it's just a simple analog color sensor, like almost like a photocell. It's not even a color sensor, it's a light sensor. So it detects the intensity of light, and it changes its resistance based on the intensity of light. And so you can feed that into the analog to digital converter on the Arduino processor, and then read, what's the intensity of the light. And just by changing the color of light that you flash with a neopixel, you can then read the intensity of light that's reflected back from an object. And if you do that for the red, green, blue colors of light, then you can kind of tell how an object reflects red, green, blue light, and which basically means what color that object looks like. So I think it'll make more sense. I'll do a quick little demo of something that we added to the Circuit Playground Arduino library just recently. So there's a color sense function that you can use, and I'll give a quick demo of it. And then I thought maybe it would be interesting in this stream to look at how to add this functionality to the Circuit Playground Firmata firmware. And so Firmata is that remote control kind of protocol for talking to an Arduino from your computer. It's a way that you can talk to a Circuit Playground with Python code that runs on your computer that does stuff like, maybe reads the sensor values or lights up the neopixels. So I thought it would be fun to add the color sensing function to the Firmata firmware so that you could write some Python or JavaScript or whatever programs that use that Firmata protocol and can read colors just using the Circuit Playground board. So cool, okay, good. Sounds like the sound is working, so hopefully all things will be good for the rest of the stream. So let's just jump in real fast to the workbench shot. And I'll show you what I've got set up here. So this is Circuit Playground right here. And by the way, I'll put links down in the description below when this goes up on YouTube so you can see if you want to find a link to this board. Real nice little all-in-one Arduino compatible with it. Has all kinds of components and things on it. We've done a lot of videos. There's a whole playlist actually of videos that I'll link to that you can look at to see more details about Circuit Playground. But I'll just show you. So this is running the color sense sketch that's an example in the Circuit Playground library. And the way it works, so when I press either of the push buttons, there's left and right push buttons, they both do the same thing. When I release them, it's going to use, so right here where my finger is pointing is neopixel number 1. The one right above it, that's neopixel number 0, and then it goes all the way around. There's 10 of them on the board. So neopixel number 1, and then right next to it, right next to my finger here, you might be able to tell, oh here, actually we can zoom in. Let's go zoom way in here, there we go. So you can see this little eye right there, that's the color sensor, and it's kind of right next to it. I keep saying color sensor, it's a light sensor. So this is a light sensor. It basically changes its resistance based on the intensity of light. So it's right next to the neopixel right there. So the cool thing is, if you light up the neopixel, it's gonna shine some light straight up, and then it's gonna reflect back down and hit that color, or that light sensor. So you can detect the intensity of the light based on that. So watch what happens when I press one of the buttons right here. So did you see the pixel? I'll do that again. So you see it flashes like red, green, blue pretty quickly, about maybe half a second or so. And then all the pixels light up. So what it's doing, it's trying to read the color of an object that's right on top of the light sensor right here. And then it lights up the pixels with whatever color it sees. And right now, like there's nothing above them, so it's just seeing the light shining down, and that's why it kind of lights up as a white color. But let's zoom back out, and I'll show you. I have some colored things here. So This is just a little notebook that's obviously red. So let's see what happens when I hold this. And I only need to hold just a little bit of it, like basically over the light sensor on Circuit Playground. Let me move this out of the way. So, I don't need to cover the whole thing. I mean, I can, but I really just need to hold it over the light sensor, or the light sensor, and the NeoPixel. So I'll do that, and I press the button, and hey, look at that. So you can kind of tell it's a red light, and it's a little hard to see the colors with the light, unfortunately, like the contrast and the exposure gets a little messed up, but it's definitely a red color. And we can try other colors here. This is a dark blue. Now this one's interesting because it's so dark. It doesn't reflect as much light, and so it's a little harder for it to read. So we'll try it. I'll press the button and we'll see what happens. So you see, it looks like the pixels aren't even lit up, and they probably are lit up, but at just a very low level because this is such a dark color. It needs to have more intensity to be visible with given the ambient light in the room. But we'll try it again. So we'll just see if we can get some of the blue. That didn't really do much. So there we go. So you can see it picked up like kind of a blue color right there. So that's good. It's at least figuring out that blue is the higher intensity of the light reflected off of there. Let's try another one. This is the pink one. And so it looks like it picked this one up pretty well. So we'll do that. And then, yeah, you can tell. And it's hard to see on the video, but it's actually a pink color for the LEDs there. And then one more, this Multimeter X-Tech. This is a really good one. We'll just put this orange cover on the back there. And then you can kind of see, it's hard to see. Actually, that one was a little more white. So let's try it again. There we go. That's a little more orange. Which kind of shows, some limitations. Like, this isn't a perfect color sensor. We actually have some really nice color sensors as standalone breakouts. The TCS 3725 or something. It's a really nice little I2C, if I remember correctly, protocol color sensor. And that one's nice in that it's a whole separate standalone chip. It's calibrated to detect colors, pretty accurately. So if you really do need like accurate color detection, look at a standalone chip like that. But just using Circuit Playground with some simple components, we're just using the light sensor and the NeoPixel right next to it. And again, you can see, when I press this, it's just flashing the lights and reading the light sensor. You can detect color, like it works. Here's the red again. You can detect that. We'll press that, and boom, there's some red color. So that's the demo of it. Let me jump in then, and I'll show you the code for this real quick. I'll show you both the example in the library and then the code in the library itself. It's really pretty straightforward to do this. So let's switch views real fast. So we'll just jump to the desktop view. So I'll show you real quick then the actual Arduino sketch that's running on Circuit Playground right now. It's this color sense example. And so if you install the Circuit Playground library and then go to the examples, it's in there right now. It's color sense, and I just added it yesterday. It might take a day or two to get into the Arduino library manager. So update your library, and then you should see this. But if you open up this example, we'll just run through the code real fast. So it's pretty straightforward. It just does some initialization. You have to initialize the Circuit Playground library. That initializes like the accelerometer and a few little things. And then in the loop, it's basically just looking to see right here, did you press any of the push buttons? And so I'm using the logic that I always use where I'll do an initial reading, I'll have a small delay, and then I'll do a second reading of each button. So I'm looking for the transitions of when you release your finger, the button's going to go from a true value to a false value because most of the time is going to be spent waiting in this delay. And then, you've got the two readings right before that delay. So you can look and see if during this delay, did you remove your finger? Did it change that signal? And you can detect that right here. So I'm just looking to see, did you release your finger from either of the buttons? And if you do that, then basically I turn off all the pixels because I don't want a lot of other light to be shining when I do this reading. So I think it's smart to just turn off all the pixels, call the clear pixels function. And then I call this sense color function right here. So this is actually the function that does all the logic. So when I press this, you can see, it flashes that little color light and reads out the pixels. And then after that, it actually prints out the color detect. So I'll show you real fast with the serial monitor. Let's see. So yeah, 115200 baud, that's what I want. So if I take this red thing and if I hold this over and I press the button, then you can see here it's actually telling me the color that it read. And so each component goes from 0 to 255, where 0 is low intensity, 255 is maximum intensity. So this is, a relatively intense or moderately intense red color, and then not much in the blue and green. So like, only 15. So like almost no blue and green, which is great. That's exactly what we expect for red. If I go back to like maybe the pink one, so we should see, I think, a little more blue. If I remember correctly, red and blue make pink. So if I do that, oh, that's interesting. It got kind of a blue color there. So you can see it, it's not perfect. And when you're using, so you can see this is like a shiny surface, like it's reflecting the light. So that makes it a little more difficult because, if I hold it at the right angle, it's actually just going to reflect all the light. And that's why it sees that it's white. It doesn't actually pick up that it's a color. So, it's not perfect. Like a matte colored object is really what you want. Let me hold it. There we go. Got kind of a pink color there. So now you can see, okay, yeah, this is a lot of red and maybe a little more blue and then some green with that. But pretty cool. I mean, like I said, it's not perfectly accurate, but it's pretty close. It's, good enough, I think, to do some fun stuff with. So anyways, we call the circuit the sense color function here. And the way it works is you have to pass in red, green, blue variables, and they have to be these uint8. That's basically a byte, so from 0 to 255. You pass in these values as parameters, and then it's going to fill in. It's going to set these values, these variables, with the red, green, blue color component values that it read back. This is a pretty common convention in C and C++. When you have multiple return values from a function, you kind of have to return them as parameters. I'm doing them by reference here, but there are other ways to return them. I do have another version of this function that actually returns a uint32 if you want. So you can say color equals circuit playground dot sense color, and you don't have to pass anything in, and then it's going to return back a single 32-bit value that has all the red, green, blue components packed into it. It's actually a 24-bit value. This is usually a little more common when you're like dealing with maybe the set pixel color function. There's a version of set pixel color that can take in directly one of these 32/24-bit color values. But in this case, since I wanted to print out the red, green, blue components, I used this version of the function. So, you have a couple options here. Use whichever one you like. But it's really as easy as calling this function. So you call this function, and it's what does the magic of flashing the light, figuring out the color. And then I just print out the color. And then right here, I just loop through and light up all the neopixels. So there's 10 pixels on the board. So I light them all up, the color that I read from the sense color function there. So that's the example sketch. And then let's just dive in real quick. I'll show you the code for this sense color function. So this is the Circuit Playground library that we're looking at right here. So here's the header file. This defines kind of the class and all the objects in here. And so I added a couple new things here. So I added the sense color function, which we just saw used in the example. So this is the one that you pass in the red, green, blue components to. And then here's the other one I was talking about that has no parameters, but returns back a 32-bit value. And you can actually see how I implemented this. I just call the version above right here that takes the red, green, blue components, and then I just, I pass in the values, I get them back, and then I pack them together into a 24-bit value that I return here. So, because I didn't want to re-implement this function again and have two implementations, it makes sense. I'll just use the implementation once up above here and then return the value back. But I figured, hey, this could save some people some work if they wanted to get a 32-bit value and didn't want to have to do all this packing themselves. So those are the two new functions, and then the actual implementation is in the CVP file. And so inside of here, this is the implementation of sense color. And you can see it's actually not super complex. What I do, first of all, I look at what's the brightness of the pixels on the Circuit Playground board, and I actually save the current brightness. So I call get brightness, because what I do is I actually set the brightness to 255, like max brightness. I want to make sure that my pixel, when I press this button, it lights up that red, green, blue as bright as possible, because I was playing with this a little bit, and if I didn't have that intensity set to a high level, or the brightness set to a high level, I was getting really weird readings. So, you really do want to make sure that you shine as bright as possible with this. But at the same time, I didn't want to just always set brightness to 255, because then that might mess with someone's sketch. So I basically save the old brightness, and then later at the end, I restore the brightness back. And then right here is where I actually do the color sensing logic. So what I do is I set pixel 1, which is, that one that my finger is pointing at. I set it to red, I wait a little bit of time, and I have a delay that I configured in the header here. So up at the top, I have this light settle milliseconds. So it waits 100 milliseconds basically, which you need some time. You know, this light sensor, it's an analog component. It doesn't instantly change. You know, the NeoPixel is pretty quick at changing, and light is really fast. You know, you're going to see it instantly. But the sensor itself, it's got to change its resistance, so that takes a little bit of time. So that's why I delay. I wait a while. And then I just take a reading from the light sensor. So this light sensor function, it's defined up above, and it's just using the analog to digital converter. It's just making an analog read call, basically. So that comes back with a 10-bit value, because the analog to digital converter on the Arduino has 10 bits of resolution. So it goes from 0 to 1023. And I save that as my raw red value, and then I do the exact same thing for green. So I light up the pixel green and pixel number 1, wait a little bit of time, grab a light sensor reading. Same thing for blue. Light up the pixel blue, wait a little bit of time, grab a blue pixel raw reading from the light sensor. So once I have those 3 light sensor readings, then I'm kind of done as far as using the hardware. So I turn off pixel 1 just because I didn't want to leave it left as a blue color. And then I restore the brightness back to whatever it was before this function was called, you know, just to be nice, so that if your sketch is changing brightness, it's not going to mess with it. And then here's where the actual logic is to convert these raw readings into 0 to 255 color values. And the way it works is it's actually really simple. Like, I started out with a really complex version of this where I did a reading with no light lit up and with the pixel lit up as full white, like, you know, 255, 255, 255 colors. Because I kind of thought, like, well, maybe I should see what's the range of like no light and full light, and then see where does each of these raw color readings fall within that range, and then interpolate that between 0 to 255. Oh, and by the way, how about sample the light sensor 5 times and average it because maybe it's noisy? And you know what? All that complexity really didn't work well. It worked, but it was more complex than it needed to be. And this is actually a version that Lady Ada made, and you know, I've just kind of made it a version I can put in the library here. But you know, her logic was a lot simpler, and I think better in this case. It's easier to understand. So all that you really do here is you say, okay, I have these raw readings. I know that they're 10 bits, so they go from 0 to 1023. I need to convert these to a range that goes from 0 to 255, or 8 bits. So just divide by 4, like scale it. So take it and say, okay, I have a value that might be at most 1023. If I divide that by 4, that gives me a value that's like 255.75 or something. But it basically takes it down into that range. And it's all proportional. So if I had a value that's halfway between 0 and 1023, you know, if I had like 512 or something like that, divide that by 4, that's going to give you around 128, which is halfway between 0 and 255. So that's really all that happens here, is we're just scaling it down from the range of 10 bits to 8 bits. And then this little min 255 thing, this is just clamping it to make sure that the value never goes above 255. Because if it does go above 255, it's actually going to overflow, because this is an 8-bit value. So it's going to wrap back around to 0, and we don't want that to happen. You know, if the value happens to be more than 255, then I just know that it's full intensity. And so this is a pretty common thing that you see, where when you want to clamp to a maximum value, you can use the min function, which basically looks at the 2 values that are passed in, and it picks the lower of those 2 values. So in most cases, it's probably this right side here, where I've taken my raw reading and scaled it down. But if it happens to be larger than 255, it's going to pick this side here as the minimum value. So it's going to clamp it to 255. And that's all it does. So it just grabs the raw readings, you know, lights up the pixels, grabs a raw reading, and then scales it down to a 255, an 8-bit value here, and returns it back. So it's just, you know, the way that I'm passing these variables, if I remember correctly, this is by reference. Man, it's been a while since I've used C and C++ stuff. But basically, this lets you pass in a variable. Normally, variables, you know, like this variable up here, it actually makes a copy of whatever you pass in. And so this wheel position variable, I can change this inside this function, and it's never going to change whatever variable called this function. However, when you put this little ampersand here, it changes how the variables are passed around, and it's actually going to give you the variable that the caller passed in. And so anytime I change red inside of this function, like I set it equal to something, it's actually changing the variable that was passed in up here. There are other ways to do this. You can actually use a pointer. So if I put a star inside of here, but then you have to dereference the pointer and it gets a little more complex. So, you know, hey, this is a feature they built for exactly this scenario. So that's what I'm using it here for. And that's it. That's the function here. So, you know, it's the color sensing demo. It's kind of cool. So we'll try it again with the red color here. And yep, look at that. It's red. Okay, so that's how it works. So I was thinking, let's dive in real quick and we'll see how fast I can do this. But I was thinking, so, you know, I created this Firmata firmware and I need to load the firmware actually. So I'll kind of show you. So in the examples for the Circuit Playground library, there's the Circuit Playground Firmata. So let's open this up. And I'm going to load this onto my Circuit Playground board. So I just want to make sure that I have the board selected. Yep. And I'll press upload. And I'll show a real fast little demo. So like I mentioned, Firmata is a protocol for remotely controlling an Arduino. And basically, if you upload this firmware, then you can have code that runs on your computer. And as long as the board is connected to your computer, like there's a serial connection that it has, your computer can talk the Firmata protocol and control Circuit Playground. So it can light up the pixels, it can read all the sensors on the board, it can read the accelerometer. I've got demos for all of these. I've done some videos on a bunch of this stuff. So, you know, see below the link to the Circuit Playground playlist, and you can see all these videos with all kinds of details. So, okay, so I loaded the Firmata firmware. By default, it doesn't really do anything. Now let's go in and let's run. So I have some Python code here that's using a little Firmata library that I wrote to use Circuit Playground. And let's just run. We'll do Python, how about pixels.py, and I have to give it the serial port of my Circuit Playground board. So if I remember correctly, it's like dev.tty at USB modem. And that should be it. So I'm just going to run this, and it takes a second. So it's using this library called Pymata. That's a really nice little Firmata implementation in Python, and it's going to open up a connection from my computer to the board. And you can see, okay, so it lit up the pixels. Now it's not animating. Sometimes this board, I think I just messed up the serial connection. So let's try this again. But basically, it's going to animate the pixels, and it's you know, basically going to tell the firmware, you know, here's what color to make this pixel, here's what color to make this pixel, and then every few seconds or so, or less than a second actually, it's going to change all the pixels. So, okay, we'll give this a second. It takes it a little while to detect, and I might have messed up the board. Like, this cable that I have is a little flaky, and when I move it around, I can sometimes mess up the board. So let me cancel this. Let me unplug and replug in the board again, and let's just check that I have a serial device. Okay, there it is. So let's try this one more time. Maybe we'll do some Firmata debugging if this isn't working super well. Okay, so it's gonna open the port, and there's a little bit of complexity. So okay, there we go. Oh, there we go. Finally, it's animating. Hopefully, I won't touch it now. So hopefully, I don't mess the cable up. But you can see, so I have code running on my computer here, and I'll show you the code real fast. You know, this pixels.py. This is the code that's running. So it's Python code. This is not Arduino code. This is not C language code. This code is not running on the Arduino. It's running on my computer, but it's telling the Arduino or the Circuit Playground what to do, basically. And so it's got a little main loop here that loops through all the pixels, and it calls like this board set pixel function that's very similar to the set pixel function in the Arduino sketches, you know, like you see in the color sense, this Circuit Playground set pixel color. Same exact kind of functionality, but this is just a Python function that's telling the Circuit Playground board, okay, light up this pixel this color. So what I wanted to do is I wanted to add a new function to the Firmata firmware that basically is the sense color function that we have in the library right here. So, you know, I want you to call this function and then have it return back the red, green, blue color values, like do the color sensing function and then return back the colors that it gets back from that. So, okay, so let's just kind of dive into this. So there are two things that I need to do. So one thing is I need to modify the actual Circuit Playground Firmata firmware. And I've done some videos on this before. So this is the code that I just loaded onto the Circuit Playground board. It's not something that people who use Firmata need to modify. Like, this is, you know, something that's hidden from you. It's just you load it up and then you write your code that talks to it. So it's a little complex, but I've tried to kind of structure it in a way that it's not too insane. And the way it works is Firmata has this whole protocol, and you have special values that identify each of the commands. So that's what like these unique values are. I have like a single value that kind of, it goes in the header. The Firmata protocol has this thing called a system extension. And so this 0x40 value is kind of the byte that defines all the Circuit Playground system extensions. And then I have a bunch of different bytes that define all the different commands I've implemented. So like you can set the pixels, you can show them, clear them, set the brightness. You can play with the tones, like there's a speaker on the board, the accelerometer, all kinds of stuff I've defined over here. So let's add some new commands then. So I know that I'm going to need a like a CP sense color command. So this is something that's going to be sent from the computer to Circuit Playground and say, hey, run the color sense logic. And the way Firmata works is, like, functions don't necessarily return data. You just pass messages around. So I'll have one message that gets sent from the computer to the Firmata board or to Circuit Playground that says, run color sense. And then I'll have another message that Circuit Playground sends back to my computer that says, hey, I ran color sense, and these are the colors that I received back. So that's gonna actually return the red, green, blue color values for this. So, okay, so for my sense color function, I just need to define a unique byte for this. And so let's just say 0x50 for this, because I've kind of had a convention where all of the pixel commands have 0x1, so like 0x10, 11, 12. The tone stuff is 0x2, accelerometer is 0x3, cap touch is like 0x4. So that's what I was thinking with this. You know, each high-level component of the board I tried to separate, because I realized, like, you know, I might want to add some pixel functions later, and it'd be kind of annoying if suddenly those pixel functions are like 0x55, but the previous one was 0x13. You know, that's annoying. So it leaves me some room to add some commands in here. So okay, so there's the sense color function, and I'll just put a little comment here. We'll say perform a color sense using the NeoPixel and light sensor. And then I know I need another command. We'll say about sense color results. I think that's the convention. Oh, reply is what I've generally used. So let's say reply. I just want to keep things consistent. And we'll say this is an 0x51 command. And so result of a color sense will return the red, green, blue color values. And let me just try to format this a little nicely. Color values that were read from the light sensor. And the way Firmata works, so I can add arbitrary parameters to a message that I send back. So I can load this up with anything. I need to send 3 bytes of data. So I basically need to send the red, the green, and the blue bytes of data. Now the annoying thing is Firmata, when you send a byte of data in Firmata, you only get 7 bits of data. You don't get the full 8 bits of data, because the high-level bit is a bit that says whether this is a command or a data packet. It's part of the MIDI protocol that Firmata is built on. So in order to send a full byte, a full 8 bits of data, I actually have to send 2 bytes of data technically. Like 1 byte that has the lower 7 bits, and a whole nother byte that just has the 1 high-level bit that I cared about. You know, it's unfortunate, but that's just the reality of it. So it just adds a few extra bytes of data. So I'm just going to make a note here. This will return, how about 6 bytes of data, and I'll just list them out. So we'll say, you know, red color, 8 bits, or how about unsigned 8-bit value, split across 2 bytes. Well, how about 2 7-bit bytes, just to make it clear. And then same thing for green and blue. So, okay, so we'll copy that. And we'll say green color and the blue color. Okay, cool. So now I've kind of defined what I need to implement here. So I basically need to listen for this sense color command being sent to the firmware. And then when I see that command, I need to do the color sense and then send back a color sense reply that packs in the data that I just mentioned right here. So, you know, smart kind of thing to think about. Like early on when I was first programming, it's easy to just dive in and start coding, and then you kind of realize like, wait, what am I doing? I don't know what I'm implementing, and it's really easy to write really messy code. So take a second, think through how you want to implement it, document it even. You know, this is kind of the spec for what I'm going to implement. And then it's nice. It keeps it kind of clear, because if you get to a point where it's like, okay, what next? Well, now I know I need to implement these two things, and it's pretty clear exactly what they need to do. And it's also good in that, like, hey, if I need to come back a week later and finish this up, I've written down what I need to do, because it's going to leave my memory as soon as I turn this camera off. Okay, so let's go down, and the way the firmware works, I have a function that I define. So yeah, the circuit playground command, this function right here gets called by the firmware when it detects a circuit playground command was sent to the circuit playground Firmata on here. And it's going to tell me, it's going to parse out the command, and then it's going to give me a buffer that has all the extra parameters that were sent with it. And luckily that sense color function has no parameters. So my firmware, my Firmata firmware, it just needs to look for that color sense function that was being sent to it, and then it's just going to get started with that. So I'm actually going to copy this value because I'm going to need to reference it below. And of course now my cat wants to play, so hey, maybe she's interested in Circuit Playground. Okay, so I've just got this massive switch statement in here that looks at each command that was sent in. So like here's the pixel set command, pixel show command, and this is where they're implemented. So like for pixel show, this is a really simple command. It parses out no parameters, it sends no response, it just calls the Circuit Playground neopixelstrip.show function. So that's like an easy one. Whereas the pixel set is a little more complex. This one needs to parse out the pixel color that was sent to it, and you can see it's doing all this crazy bit manipulation because the Firmata firmware, or the Firmata protocol, uses 7-bit bytes, and so you got to do all these gymnastics to pull out your values. But that's what's happening in this big switch statement here, is just every command is being processed. So I'm going to add a new case here for the cpSense color command. So if I get this, then basically what I need to do, I need to sense the color of an object over the light sensor and send back a cpSense color reply response. Okay, so for this then, I need to call the Circuit Playground.sense color function. So I'm going to do that, and in order to call that function, I want to get back the red, green, blue color component values. So what I need to do here, I need to create a red, green, blue variable. So these are going to be just unsigned 8-bit values that I can pass into the Circuit Playground. Oops, let me spell this correctly. Playground.sense color function. So we're just going to pass in red, green, blue, exactly like I use in the example sketch here. And then one little tricky thing that I know because I've done this a lot, when you're in a case statement like this and you try to create local variables, they're actually not local to the case statement. It's actually going to pull them out, and I think you have to define them up ahead of the case statement. It's kind of an annoying thing. And it's also maybe a sign that like your program's getting a little complex and you really shouldn't be putting all this logic in a case statement. Like I should probably have a function that I call. But the way I can work around this is if I explicitly put curly braces here, this is going to make a block. And then inside the scope of this block, it can create these variables and not complain about it. So just a weird thing. Really, I probably should just have this call, like do maybe like a do color sense function that implements all this logic, and it can be as complex as it wants, but I'm just going to keep things a little simple for now. Okay, so I'm going to do the color sensing, and then I need to return back a response. So I need to send back a response. And I've kind of done this, I created other little sub-functions here, like send an accelerometer response, send a tap detection response, send a capacitive touch response. So I'm going to follow that same convention, and I'm just going to create a new function here, because I could put all that logic inside of here, but again, it starts to get really complex, and I wanted to keep things a little simple. I want to be able to just look at each of these case statements and really quickly figure out what they're doing. So if I start jamming more code in there, it gets a little more difficult. Okay, so I'm just going to copy the tap response, and we'll say send color sense response, and we'll say send a color sense response back to the host computer. And you know, now that I'm thinking about it, maybe since this is so simple, let's just have it read the color inside of the send color response. So this way I don't even need to worry about doing that funkiness with creating a scope there. Okay, so I'm going to read the color, and then let's see, we'll come back and we'll start adding some code below this. So in my case statement, I know for sure then I just need to call send color response. So that's going to call this function down here, color sense response. And then, okay, the first thing this function is going to do, it's going to read the color. So after this line, my red, green, blue variables have the color values. And then now I basically just need to pack this into an array of bytes and call this firmata.send sysx command. And this will send the data back to the host computer here. So you can see the previous function, it was getting the click state, but I don't need to do that. But I do need to construct a response data packet. And for this data packet, so it needs to include the very first byte needs to be the identifier for this command. And so way back at the top, I created all those two identifiers. So let me grab the second one. So this is going to basically be the little magic byte right here that says, hey, this is a color sense reply command. And so let's go all the way back down to this function. And now I can say, okay, so the first byte needs to be this value because that identifies this packet of data as a color, a sense color reply. And then after that, I need 6 bytes because remember, you know, I said I need to split the data up across, because I'm sending a full 8-bit byte of data, the MIDI protocol splits it up into 2 bytes of data. Now, if I remember correctly, this firmata.send sysx command actually does that expansion automatically. So for every byte of data that I send to send sysx, it actually breaks it into 2 bytes of data that gets sent to the host machine. So we'll see when I add the Python logic to read this why this matters. But this basically means that I really just need 4 bits of data to send back. So the first one is the byte that identifies the type of the reply. The next one is the red color, then the green color, and then the blue color. So basically I'm just sending 4 bytes, the identifier for this packet, red, green, and blue color, and that's it. And then the send sysx command, you send it the high-level sysx ID, which is this constant I've defined for Circuit Playground, like it's OX40, and then you define, then you pass it in a buffer of bytes, like an array of bytes, and you have to tell it how many bytes. So I have 4 bytes, and then data right here. These are the 4 bits of data that I'm passing back in. So okay, so that should be it. Like, as far as I can tell, this is really all that I need to add. So I've added a new command that it's going to listen for, this sense color command. It has no parameters. It doesn't need to, you know, parse anything out, which is good. It's simple. And then it's just going to call send color sense response, which is going to call that sense color function, read the color, and then construct a packet of data to send back using this sense color reply. And pack in the red, green, blue values inside of there and send it back to the host computer. So, okay, let's save this and let's see, let's open up this Circuit Playground Firmata firmware example. So let's see, let me open up this file and let's go to, I need to go into the repositories and it's in here. And okay, so let's open this guy up. And this, we should see my code inside of here also. So let's just make sure that I see, yeah, there's sense color reply. Okay, let's make sure it compiles because, hey, it's always easy to make a little mistake here, compiling the sketch. And by the way, if people see the spurious.github folder warning for Adafruit's libraries, we just made a change. We put some templates in. If you open an issue or a pull request, it kind of gives you some tips to say like, hey, you know, thanks for contributing, and here's some pointers on how to, you know, raise an issue, like don't use issues for tech support, that type of stuff. Unfortunately, Arduino kind of complains about this, but in the next version of Arduino, I think they're going to patch it so that it ignores this .github folder. Anyways, it compiles, so that's good. So let's load this firmware onto my Circuit Playground board. So let me make sure I've got it selected here. Yep, it's all selected. We'll press upload and let it do its thing. and it takes it a second here. It's got to open the port. There it goes. It's sending the firmware. Okay. And let's see. Oh, and by the I just noticed. I'll try to answer comments at the end. I'm kind of like right in the middle of the coding here, so yeah. Hopefully, in maybe another 20 minutes or so, I'll try to make this like an hour stream. But yeah, so feel free to throw questions into the chat, and we'll come back to them. Okay, so my firmware is updated. I think I've got all the logic inside of there. Now, from the Python side, I need to write the code that can send this command when requested, and can parse out the data that comes back, from this send sysx, so that can parse out the response. And the place that I want to do that is in this circuitplayground.py. So this is in this Circuit Playground Firmata library. I'll put a link down below. It's actually this GitHub repository right here. So this has both the firmware that we were just looking at, this circuitplaygroundformata.eno, and then there's also the this Python code that I wrote. And you don't have to use Python for Firmata. That's the cool thing. Like, there are JavaScript. I mean, pretty much every programming language has a Firmata library. Now, you do need to do some custom stuff to use all the Circuit Playground specific stuff, because Firmata only defines like digital read, digital write, analog read, analog write, which all of that stuff you can use on Circuit Playground. But if you want to use like NeoPixels, for example, you need to know which pin the NeoPixels are connected to on the Circuit Playground board, how many NeoPixels are on the board, that type of stuff. So that's what my Python library does, is that it knows all that stuff. It knows those extra Firmata commands that I added, and it makes it a little bit easier to use them. So, okay, so to get started, I kind of have to mirror the exact same thing in my Python code. It needs to know the exact same constants as my Arduino code. So I'm going to go back to the top, and let's see, that's the color sense function. So let's close that one. Yeah, there's the firmware. And so I need these defines, and I'm just going to copy them out exactly as they're defined in the Arduino sketch. And we'll just delete these, and we'll convert this into Python real quickly. So that's pretty easy. Yep, we'll just select all those, turn those into comments, and then let's fix up the indentation right there. Oops, a little bit too many. There we go. Okay, cool. So I've defined my two constants. So now what I need to do, so I have this Circuit Playground class, and then it defines a bunch of functions. So if I go down, like, here's the clearPixels function. So when I call circuitplayground.clearPixels in my Python code, it's actually going to call this function here, which says, okay, send a sysx command using that magic Circuit Playground byte, and then here's an array of bytes to send. So it's sending the pixel clear command, like we saw, in the definition of the firmware here. Oops, let's go back up here. So like, here's the pixel clear command. So when my Python code calls this, it's sending a pixel clear command byte, and then the firmware parses this. It gets the pixel clear command byte and then performs the action here. So I want to add a new function at the bottom here. So let's go all the way down, and let's add a sense color function, because I want to make this as close to the Arduino code as possible. So we'll say sense color is a new function. It's not going to take any parameters, because the nice thing with Python, you can return multiple values. You can return a tuple, which is just a set of values. So I don't need to do all that reference stuff. But I do want to document this, so I'll say, okay, perform a color sense using NeoPixel number 1 and the light sensor. Will return the red, green, blue color values that are read from the light sensor. And I was just thinking as I wrote this, so there is actually going to be a little bit of complexity here. So I'll show you the problem. We can just kind of start real quickly. So the first thing I need to do, I need to send the color sense sysx command. So I'm just going to use the same kind of logic as I had up above here. I'm just kind of stealing some of this code. Okay, so I need to send that Circuit Playground command byte, and then I need to send it a byte that is the sense color command. So if I go way back up to the top, I need to grab this magic byte, so this 0x50 value. And I just need to send an array that only has that byte, because there's no parameters to this function. So this should be enough to tell my Circuit Playground board, okay, perform the color sense and return back the value. So let's actually save this, and let's make a quick little demo example. So let's grab, I'm trying to think of like what's a simple example that I had in here. How about the pixels.py? Let's copy this and let's make a new, let's paste this in. So, and then let's rename this and we'll say this is color, about sense color.py. Okay, so this is just some boilerplate setup code. Basically, I'm importing this Circuit Playground class that I was just modifying. I'm making sure that you send in the serial port because it needs to know that when it creates a Circuit Playground object. And then here is where I actually do all the board logic. So I'm just going to delete everything right here. It's smart to call board.close at the end just to make sure that you close the serial connection nicely. But let's just call board.senseColor inside of here. So this is going to call the function that I just implemented right here, which is going to send this sysx command. And if everything goes right, now I'm not going to get anything back because I haven't put any logic in to read the response packet, but I should at least see the little pixel light up on the Circuit Playground board to tell me that the Firmata firmware parsed out, it saw the sense color function sent to it. It called this send color response, which called the sense color function, which causes the pixel to light up. So in theory, if I run this Python example here, so let me make sure I've got the example, and if I run the sense color.py, and I need to give it the serial port again for USB modem. Okay, so let's see what happens here. I'm gonna watch the pixel on here, and we should see it light up and flash. It takes it a second for it to open the serial port. So we'll give it a second. Hey, okay, look at that. It did. Now you might have noticed, I noticed another pixel flashed, and I think that's just some noise from the NeoPixel, basically the signal being sent out. Like sometimes it can pick up some noise, but let's run it again. I just want to make sure that everything looks like it's working. So I'm just going to hold this towards me a little bit, and we'll give it a second to connect. So, okay, there we go. So that lit up. That is really weird why this pixel down here seems to be lighting up. That's kind of funky. I just want to look real quick. I'll investigate that later. I'm not exactly sure why that pixel's lighting up because it's just calling the sense color function right here. So this is actually what's lighting up the pixel. So I'm not sure why that one lights up. That's kind of bizarre. It shouldn't affect us. So we'll see what happens. Okay, so I know that this is happening. I know that this code is getting called. I know that it's constructing this response and sending it back. So now I need to receive this response. And here's where it gets a little annoying and tricky with Firmata, at least the way that I'm using Firmata. This is kind of asynchronous code. This is similar to like JavaScript code and like Node.js because, I'm sending a command to the Firmata board, and then I need to wait for the Firmata board to send me back a response. And the way that happens is anytime my Python code receives something from the Firmata board, it calls this response handler function right here. And so this actually has logic. It looks to see, is this like an accelerometer response? Is this a capacitive touch response? And here's where I could put in code that says, is this a color sense response? And parse it all out and get that logic. The trouble is, okay, this code is going to happen separately from this function that's called right here. So, I need some way to like wait for the response from the Firmata firmware and then, return the response color data. And so this gets a little tricky, and the convention that I've kind of followed here, so if you look at some of these functions that do this type of thing, like, let's see, this read cap touch function, for example, this sends a command that says, hey, do a capacitive touch read, and it sends some parameters to it. And then what you have to do is you pass it a callback function. So you pass in this function, another function, and then what happens is it saves the function that you passed in, and it will call the function you passed in when it gets a response back from the board. So it saves that callback in this cap callback variable, member variable. And if I go back up to this handler, then we can see where I use this. So in the cap touch reply, I'm actually looking to see, okay, if I have a callback function defined, then call that callback function and pass it in some values that were parsed out. And if I look at like a CapTouch example, you can see the way it works is you call read CapTouch and you pass it a function, which I defined ahead of time right here, which says, okay, you know, when I get a CapTouch value, like this just prints it out, for example, but it could do other things. So I think I'm gonna follow that same convention with the color sensing. You know, there are other things like I could do some multi-threading and stuff and have like a mutex that this thing waits on, and then, you know, this read handler can alert that, you know, that, hey, I have a value now, and you know, and it can return that value back. But I'm gonna keep it simple for now, and I think the callback way is the easier way to go. So I'm gonna take a parameter here, and I'll just document this. So callback should be a function that will be called when a color response is received from the board. This function should take 3 parameters: the red, green, blue byte values that define the color. Okay, so I know I need the callback, and I know I'm going to need to save this callback. Probably, let's see, I'll save it as, let's call this, how about sense color callback. Okay, and so this comment doesn't really matter anymore because I'm not going to wait. So I'm gonna save whatever callback the person passed into me. And you could say none, like you could choose not to pass a callback, which means you're not going to get the response bytes. Which is fine, like it's going to trigger the color sense logic, but you're not going to get anything back, and maybe someone wants to do that. So that's why I said let's just give this a default value of none, so it's an optional parameter. Okay, so I save the callback, I send the command, and now I need to add the logic to parse that response. And before I do that real quick, I do want to go up to the initializer here, and I just want to make sure that that color sense, or no, sense color is what I called it, callback, equals none. I want to make sure that when you create this class, all of the callbacks default to none. That's just a good kind of best practice. It makes sure, you know, it makes my parse Firmata, my Firmata response handler a little simpler. It doesn't need to worry about like, well, what if I managed to get a response back? You know, maybe my board, as soon as I connected it, was sending data back before it's fully initialized the class. And then, you know, at that point, it's like I might have variables that haven't been initialized yet, and Python can treat that in a different way, and it makes your code really complex. You know, basically, I know I'm going to use that variable as a member of this class, so I want to initialize it to something. And none is a perfectly good value, so I can use that. Okay, so now in my logic, in my code here, you know, this is basically just logging back the responses and things that it gets. And actually, this reminds me, I can turn on debug output, and we should actually see the command coming back. So I'll do that next. You know, maybe, how about this? Let's add a little else if clause in here. So else if the command equals the CP, I think it was sense color reply. Then let's just print out, you know, color received. I'm not parsing the data yet, but I should at least be able to, you know, see that I received that. And you know what? Let's call our callback. You know, if self.sense color callback is not none. That's how you check if a variable isn't none. Because I do want to check this. If I try to call a function that's set to none, Python's going to fail. Like, it's going to throw an exception for that. So you do need to be careful and make sure that this has actually been set. But otherwise, then let's call this function callback. And remember, I'm going to pass it 3 variables, the red, green, blue colors. And for now, let's just set these to like 0, 128, 255, just some junk data, because I'll go back to my example here. And so let's define a function. So let's say color, and this should take the red, green, blue color values, and let's just print them out. So we'll say received red equals something, green equals another thing, and blue equals a third thing. And then if I use the format function, I can just pass those in. Okay, so now what should happen? You know, I should still see the light up when I run this. I should see this print out that I received red, green, blue, but because I haven't implemented that parsing logic yet, I should see that it received 0, 128, and 255. So let's save that, and then let's run this again, and let's see what happens when okay, so I got something wrong. Hey, this is the most common mistake in the world. I'm sure people saw as I was writing this. Double equals versus equals. Now, fun thing, if this were C or C++ code, this would not have been a warning. This would have compiled. It would have set command equal to that and then returned the value of it, which would have meant nothing. This would have been a very subtle bug. I would have been scratching my head. At least in Python, they kind of realized like this is the error that everyone makes. So let's fail in a good way with this. Oops, I forgot to save it, I think. So yeah, there we go, save it. Now let's run this. Okay, so let's see what happens here. So we're going to run this example. It's going to connect to the Firmata firmware. We should see the pixel flash, and then we should see, okay, cool. So let's see. Okay, it doesn't look like I called my function yet. So, because I should have seen this received, I know why. Again, people probably watching this are like, you idiot, you forgot to pass the callback. This is an example. I made the callback optional, which means I can call it without specifying the callback, but I should probably say callback equals color here, or I can even just say color, like that's the only parameter it takes. Okay, so now it knows that it needs to call this color function. Before, it didn't know that it should call that color function, so it didn't call it, and that's why it didn't print it out here. So let's try this again, and hopefully we should see it print out 0, 128, and 255 as the color value that it received. So we'll give it a second here, do its thing, and there, oh, hey, it didn't do it again. Wow, uh-oh, I've really broken something now. So, okay, so let's debug this a little more. Let's turn on some of the debug output. So if you noticed in this, like I have a feeling this code is not being called, like something's wrong here with the parsing of this logic. So let's turn on this debugging so I can see like what's the data that's coming back from my from the Firmata firmware board here. So to do that, I need to enable debugging. So I'm going to say import logging, and then there's this nice little logging.basic config function you can call, and if you pass it in a level, you can say the level is debug, so I want to see the debug messages, and that should be enough. It's going to just print these out to the standard output of the example here. So okay, let's run this now, and let's see. I should see a lot more data coming back. Like I should see at least the response from the Circuit Playground board here, and oh man, I didn't see anything, so that's really interesting. Okay, so it kind of tells me that I think I know kind of what's happening here. So here's the tricky thing, again, because this is asynchronous code, I'm just calling sense color. That's firing off the message that you saw, right here. And then my program goes on to the next statement, which says close the board connection. So I'm basically saying, send me the color. By the way, I'm done. Close the connection, and I'm never going to get a response back. So again, hey, I haven't done this before. So these are the kind of little things that you work through as you do things. So I kind of need to wait here a while. The easiest thing, I could just say time.sleep, let's say 5 seconds. Like that should be long enough to get a response back. But again, it kind of makes me think like maybe I should structure this example in a different way. Like maybe I should have this go into a loop and like, every second do a color read and print out the color that it received. That's maybe the easiest thing, but for now, let's just do a delay and let's see what happens here. So, okay, so now I should hopefully be giving enough time to get a response back, and I've turned on the debug stuff, so we should hopefully even see like the raw bytes of that response. And then, okay, hey, now things are looking a little bit better here. So now I see my color received, and there I see I received 0, 128, and 255, which those are the values that I just kind of pre-canned, put inside of here. Here's the cool thing though, because I turned on that debug output, this is the raw string of bytes that were received back from the Circuit Playground board, and that's just from the Firmata firmware. So that's this set of bytes here. Now you might notice, so hex values for every 2 characters here, that's a single byte in hex. So notice there's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 bytes of response, but I only sent 4 bytes of data. And that's that little expansion of 8-bit values sent as 7-bit bytes, which means they have to expand into 2 bytes of data. And the way that this send sysx function does that is it takes the lower 7 bits of data and sends that as the first byte. And then in the second byte, it sends only the high bits at the end. So the top 7 bits don't matter at all inside of here. It's only that last bit, which in this case, 0, 0 means that last bit is 0. So this value right here is really just 0x51. And same thing right here. So 1D is the value that it passed back. So the 7 low bits are 1D, and then the upper 1 bit is 0 again for this. So I need to basically pull out each pair of bytes and then look and see, put them back together as an 8-bit value. So take the low 7 bits and add on that top single bit from the second byte that was passed in. So let's do that logic. I've done that a lot actually, because all of the parameter parsing has to do that pretty much in the Python code right here. And you can actually see I have a little parse Firmata byte function here where I implemented that logic because it's so common. It's dumb to keep repeating that logic. So you can see what I do right here. So I pass in, a couple bytes of data. I make sure that I actually got 2 bytes of data because I need 2 bytes to reconstruct a full byte of data. And then right here I say, okay, grab the first byte and the low 7 bits. So 0x7f, if I look at the calculator real quick, and let's put it into the mode, programmer mode. So if I put in hex, let's see, where's hex? There we go. So if I put in 7f, now look at the binary value down here. So 7f means, the high bit is 0, but every other bit is a 1. And so when you do a Boolean AND operation here, I'm basically saying take the low 7 bits from the first byte. And then this next thing, I'm saying, okay, for the next byte, and it with the value 0x01, which if we look at that, you can probably guess just that low bit is set. So this is going to pull out the low bit from the second byte of data, and then it shifts it over 7 positions because even though it's the low bit in this second byte, it's actually the high bit in the final byte that I want to get back. So I need to move it into that high bit position. And then this OR basically combines that low 7 bits with the high bit to give you a full byte value back. And if this is kind of confusing, it's something where you just need to do a lot of Boolean operations. Just play around. Like in Python, you can just open up the interpreter and just start messing around. If you want to say like, open up Python and say foo equals 0x255, like what happens if I AND this with 0x, 03? So what value to get back? And think through and think about the byte value. You can actually do bytes in Python and bits in Python too. So if I want to say like foo equals ob110010, something like that, and then if I want to AND it with, how about the byte values, how about this? So this should just pull back, it's going to return back a 1 in this high position right here. So if I see that, that gives me 32, and I forget what's the way to convert 32 into binary, into a binary string in Python. Anyways, convert that in your calculator and see, which bit is set. But you should see basically this value there. So just something fun. It's Python is nice in that you can just open up a console and start messing with things. Okay, long story short, I need to parse out these bytes. I've got a function to do that, luckily. So let's add in that logic. So right here, I need to pull out, so I'm just going to say parse out the red, green, blue color bytes. Okay, so, and before I do that, I do want to do a quick little check. I want to make sure that I have at least enough data. So, I need at least 6 bytes of data. 2 bytes for red, 2 for green, 2 for blue. So I want to see if the length of my data, and the way this function works, the data passed in is just an array of bytes. So if this is less than 7, because it needs to include the 6 bytes for my color data, actually 8, sorry. The 6 bytes for my color data, plus, remember, there's this byte at the start here, which actually expands into 2 bytes. This byte that identifies this as the sense color reply. So if I have less than 8 bytes of data, in the response, then something's wrong. Like I didn't get enough data. So I should just throw a warning here. So we'll say logger.warning. That's kind of the convention I have. Received color sense response with not enough data. And then I'm just going to return, because remember, this happens asynchronously. I'm not returning like an invalid result. I'm basically just swallowing the error, which I don't like, but at least I'm sending a warning here. So if you turn on warnings, like you could actually just say logging level warn instead of debug. That'll print out warnings that you see like that. So I need some way to at least know that something went wrong. Now this should never happen. Like my firmware, I know I'm sending 8 bytes of data right here, but just in case it happens, it's smart to handle that. So okay, so now I can parse out. So we'll say red equals self dot parse Firmata byte, and I need to pass it the second 2 bytes of data. So, or not actually the second. So, these first 2 bytes are handled as the command parsing. So that's, this command value gets them. So that's bytes 0 and 1. So then 2 and 3 are the next 2 bytes, and that's my red color. So I'm going to tell Python, grab bytes 2 to 4. And the way that this slicing syntax works in Python, you pass it the first byte, and or the first index, and it's going to grab that value, and then it's going to grab every value up to, but not including this second index value. So it's going to grab value at index 2 and 3, but it's not going to grab at index 4. So just a little gotcha, something to remember with Python. And then green, so I need to grab the next value. So we'll say parse Firmata byte. And here I want to say from 4 to 6, so the next 2 bytes. And then blue, I'm going to say parse Firmata byte. And we'll say from 6 to 8. So that should be all the values that I need. And that's going to give me back those byte values. And then let's just pass them to the function that I'm calling. So we'll say green and blue. Okay, cool. So let's save that. And now let's see. I'm going to remove this color received because I don't really need that anymore. So, okay, so now let's run our function, our example rather, and I'm going to hold this red thing over it. So let's see what happens. And it takes it a second here to, connect and do the color sense. And then we should hopefully see that it figures out the color. So we'll give this a second. And okay, so notice this. It got a response back, and it received red value 48, green 5, blue 5. So that's telling me it picked up. This is a mostly red thing that it received. So that's good. So let's try something else. Let's try a blue thing. So this is the dark blue one, which sometimes shows up as black, sometimes shows up as like darkish blue. So let's see what it reads from this. So we'll give it a second here, and it's going to connect, and then hopefully we'll see. And we get back, okay, so yeah, it's a pretty dark blue, blue 11 at least, that's a higher component. So that seems like that's working. Let's try the pink thing next. So here's the pink thing. And if I remember, pink is mostly red, but a little bit of blue inside of there. So, okay, let's hold that over, and we'll run this example again. Okay, cool. So we'll give this a second, do its thing. And I think we're getting a value. So there we go, yeah. So a lot of red, but also a little bit of blue, and then some green there. So cool, I think that that's working. Now, if I wanted to go further in this example, I could look at like the NeoPixel example, so you can see how I can use like the board.setPixel function. Like maybe I could make a loop where every second it reads a color and then sets the pixel to that color. Or maybe it waits for a button press. So, there's a button example here. You can read the button press states. And then maybe that sets the NeoPixel colors, basically exactly like the Arduino sketch that I was showing before. But I'm not going to do that yet. I think I'm just going to keep this example simple. But like I said, maybe I should put this into a loop. So how about let's do loop forever, reading the color every second and printing it out. So let's do while true. We'll say sense color. And then let's do time.sleep for 1 second. And just to be nice, let's say print reading color every second, press Control C to quit. Okay, so let's try this now. So this should just be running all the time. And then whenever it detects color, it should print out because it's going to call this callback function. And maybe let's say detected instead of received. So, okay, look, notice this. So every second, okay, interesting. So it's not flashing that. So yeah, it must have, I think it's some noise from when the Firmata connection is made. It probably puts the NeoPixel into like the output pin into a high impedance state where it can read noise, and it probably queues up a bunch of noise so that the next time I actually do a pixel write, one of the later pixels gets confused and says, "Eh, you sent all these bytes before, and now I'm seeing other other bits, and so I'm going to light up." So that's probably why it's confused. But okay, so it's reading color, and let's see. So it's receiving nothing, like it's just getting noise. If I hold my my red thing above this, then I should see every second or so. Yeah, there we go. So there's a red thing, and then here's a pink thing. So if I hold that over it, then yeah, you get some red and some pink, and some blue inside there. So cool. So I think that's working. So I'll close that, and then I don't need this debug stuff anymore. So I'm just going to delete this from here. And so now there'll be a little bit less noise. But that's it. So the stream's kind of run a little bit long. I think I'll wrap it up now. I'll jump in and see if anyone had questions. We'll see if we can run through those real fast, and I'll jump back to the main camera shot here. So, okay, someone was wondering, what's this channel about? So if you're still around, so this is Adafruit. We build all kinds of electronics and fun things that help make electronics accessible. So check it out if you're interested. If you like programming, if you like electronics, even if you don't, if you're just curious what the heck is an Arduino, watch our channel. You might learn some cool stuff here. Let's see. Someone was curious about what we were doing. So yeah, this is basically, we've added color sensing detection to Circuit Playground. And so what program do I use to code this? I'm using the Atom text editor, ATOM. It's a nice little open source editor, GitHub actually, they created it. I like it, but I'm not a zealot about it. Everyone has their own favorite editor. Try a bunch of stuff. I just did a quick look 2 weeks ago on Visual Studio Code that's a similar text editor from Microsoft, based on the same code base as Atom text editor, this thing called Electron. But real nice little editor. I was actually impressed with it, so check that out. But I like Atom. Let's see, what else? I think that was it. Yeah, that was the only question that we had here. So cool. All right, so I'll wrap it up. So subscribe to youtube.com/Adafruit. You can see this video, all kinds of other fun project videos and things up there. Twitch.tv/Adafruit. You can watch me stream these things live. And maybe you can watch when I have live microphone problems like last night. But hey, we'll fix things when we come back. We just keep going. But anyway, subscribe to those. You can see all kinds of live shows. So we have Desk of Lady Ada. You can watch Lady Ada design. You can watch her design all of Circuit Playground. There's a whole series of videos. There's at least 4 or 5 videos designing the board, bringing up the initial prototypes, all kinds of cool stuff with that. So there's really tons of good content. And then 3D printing, Noah and Pedro have layer by layer and all kinds of fun stuff there. So stay tuned for all kinds of cool, good stuff there. Otherwise, I like to stream a couple times. So on Mondays, I do a quick look at different Raspberry Pi stuff. Fridays, I like to do a in-depth Raspberry Pi stream. And then in the middle of the week, I've been doing kind of random streams like the Circuit Playground one. And so today, Friday, actually later this afternoon, I'm going to do another stream. So I'm going to do the 4th part in the SQLite sensor storage series. So I'm thinking maybe we'll play with another database engine like MySQL or PostgreSQL. And what the heck, I'm going to do it again. So hey, you get 2 streams from me today. It's going to be a busy day. But otherwise, yeah, like, comment, subscribe, let us know that you like these videos, and we'll keep making them. As long as we're helping people, as long as we know that we're helping people, we'll keep going here. You guys keep us going. So that's it. I'm Tony from Adafruit, and this was Circuit Playground, Color Sensing, and Python Firmata.